Next problem is a square lead slab of side 50 centimeter and thickness 10 centimeter is subjected to shearing force on its narrow face of 9.9 into, let us consider 9 into 10 to the power 4 Newton. The lower edge is riveted to the floor. How much will be the upper edge be displaced? So you can consider the diagram like this. So lower edge is riveted to the floor. Here we are applying a force, tangential force or shearing force. Its side value is given 50 into 10 to the power minus 2 meter, that is 50 centimeter, and the thickness is given as 10 centimeter. Then area becomes 50 into 10 to the power minus 2 into 10 into 10 to the power minus 2. So area value becomes here 500 into 10 to the power minus 4 meter square, or you can consider A equals 5 into 10 to the power minus 1 meter square. Okay, sorry, 5 into 10 to the power minus 2 meter square. This is the value of area. Then force value is how much? Force value is given as 9 into 10 to the power 4 Newton. This is the value of force. We have to find the upper edge displaced means. So by applying a tangential force, the lower edge will become fixed. There is a relative displacement between upper edge and lower edge. This angle is theta. This displacement is delta x, and this length is L. For this you know that the rigid modulus formula. The rigid modulus formula eta is equals to F by A into theta. So this equals F divided by A. Theta means delta x by L. So delta x equals F L divided by A into eta. We have to substitute the values here. Then we can able to find the delta x. This we have to find in this problem. So F 9 into 10 to the power 4 and L, the length here 50 into 10 to the power minus 2 divided by area 5 into 10 to the power minus 2 multiplied by eta. Eta means like y. This is called rigidity of modulus. For different materials the value is different. For the lead the value is given. Okay, this is also considered the value is given in the question. So eta value is 5.6 into 10 to the power 9. So this is the rigidity modulus of lead. You can see in the table in NCERT book different values for different materials. So we have substituted all the values. Then we have to calculate delta x. Delta x equals, here I can 9 into 50 means I will make it as 5 into 10 to the power minus 1. 9 into 5, 10 to the power minus 1, 10 to the power 4, that is 10 to the power 3 divided by 5 into 5.6 into here 10 to the power minus 2, 9, 10 to the power 7. So find the value of delta x. So delta x value will get nearly 1.42 into 10 to the power minus 4 meter. This is the displacement of upper edge delta x. And remember the value of eta for lead. The value of eta for lead, that is, here I written right, 5.6 into 10 to the power 9 Newton per meter square. So these values will give in the question. And in the next problem, a steel wire of length 4.7 meter. A steel wire of length 4.7 meter and cross sectional area 3.3 into 10 to the power minus 5 meter square stretches by the same amount as a copper wire of length 3.5 meter and cross sectional area 4 into 10 to the power, that is not here, 10 to the power minus 5 meter square under a given load. What is the ratio of Young's modulus of steel to the copper? So directly I will write a ratio of steel Young's modulus Ys divided by Yc. This value we have to find. So for Ys, under a given load means force is same, like that you have to consider. So Fs is equals to Fc is equals to F. So F I written here, and length of the steel divided by area. Areas are different, right? Here the area of cross sectional is 3 for steel and for copper is 4. So for that I will write area of steel into delta LS. Stretches by same amount means I can also consider change in length in steel is equals to change in length is copper. So I will consider it as delta L. I will not write delta LS. So this is the value of Ys. Similarly, Yc value if I write, then I will get as AC delta L divided by FLC. So substitute the value of Ys, and that means write the formula of Ys, formula of Yc, you divide, you will get in this format. Then force will get cancelled because force is same and change in length is also same. Delta L will get cancelled. The ratio of Ys by Yc becomes Ls by Lc into Ac by As. So now you have to substitute the values. Ys by Yc is equals to Ls, length of steel wire 4.7 by length of copper. Length of copper is 3.5. Length of copper wire is 3.5. And area of cross section of copper. Area of cross section of copper is 4. 4 into 10 to the power minus 5. 4 into 10 to the power minus 5. And area of cross section of steel. Area of cross section of steel is 3 into 10 to the power 3 into 10 to the power minus 5. So here 10 to the power minus 5, 10 to the power minus 5 will get cancel. So calculate the value of Ys by Yc. So this equals, first find out what is the value of 4.7 into 4 divided by 3.5 into 3. Okay, I'll check. So you will get the ratio as 18.8 divided by 10.5. Okay, 18.8 divided by 10.5. So nearly the answer Ys by Yc, the ratio you will get 1.8. 1.79 you will get, we can write it as 1.8. And next problem. 2 wires of diameter 0.25 centimeter, one made up of steel and the other made up of brass are loaded as shown in the figure. That figure I will draw now. So consider this is the diagram. In the diagram, one is made up of steel. This is a steel wire. Okay, its length is steel wire length is 1.5 meter and a load is given to the steel wire, that is 4 kg. And next one, brass wire length is 1 meter, steel wire length is 1.5 meter, the brass wire length is 1 meter, and let us consider 6 kg block is attached to brass wire. This is brass and this is steel. Okay, this is also that means itself a question. So the length is given as 1.5 for the steel wire, 4 kg block is added, and next for the brass wire length is 1 meter, and how much weight is added means 6 kg weight. What we need to find here, compute the elongation of steel and brass wire, and 2 wires of diameter, area is same, diameter is same. So separately we have to find the change in length in steel wire and change in length in brass wire. For that, the basic formula, y equals FL divided by A into delta L, then delta L, change in length for steel I will calculate, delta LS is equals to Fs, the load attached to steel wire is different and the load attached to brass wire is different, that is force on steel wire, then LS I will write divided by AS and here YS. Okay, in this formula substituting the value we can able to find the elongation produced in steel wire. So for that, what is the area? Area of the wire, pi r square. So area is equals to 3.14 into r square. Diameter is given 0.25 divided by 2, 0.125 you will get, that is 0.125 into 10 to the power minus 2 whole square. Okay, r square. So this is the area of the wire, 3.14. So 0.125, this value you calculate, how much you will get, how much value you will get means you will get the answer, that is 0.049. Let us consider 0.049 into 10 to the power minus 4 meter square, or you can consider this is a 4.9 into 10 to the power minus 6 meter square. This is the area of the wire. So we have calculated the area of the steel wire and area of the brass wire, both are same only. Why? Because the diameter is same and lengths are different. So I will substitute here the elongation produced in steel wire. So you can see in the diagram, for the steel wire the total load attached is 4 kg and here 6 kg. Totally it is 10 kg. So force means you can consider, here only I will write F equals M into G. So mass is given, total mass is 10 kg for steel wire, and G means acceleration due to gravity. Then F value I will substitute here, that is mass is 10 kg into acceleration due to gravity, take it as 9.8, its value is 9.8 meter per second square, and length of the steel wire is 1.5 divided by area. Area, we have calculated the area of the wire, that is 4.9 into 10 to the power minus 6 multiplied by Young's modulus of steel wire. Young's modulus of steel wire value is 2 into 10 to the power 11. So if you calculate, you can able to find the change in length produced in steel. So here 2 into 4.9, that is 9.8. This 9.8 and 9.8 will get cancelled, and in the numerator here you will get 10 into 1.5. You can write it as a 15 divided by 10 to the power minus 6 into 11. So 10 to the power minus 6 into 11 means here 5. That 5 goes to numerator, means minus 5. Okay, 1.5 into 10 to the power minus 5 meter. 15 into 10 to the power minus 5 meter. You can write, or change in length produced is 0.15 millimeter. This is the elongation produced in steel wire. Similarly, with the same formula, you can find the elongation produced in brass wire. For that, what you have to write? The change in length in brass is equals to FB, that means force of brass, into LB, length of brass, divided by area. Same, area of steel and area of brass is same, but here Young's modulus of brass. So here elongation in brass, that is force. For the steel wire 10 kg is added, for the brass wire if you see the diagram only 6 kg is added. So here in the place of F I will write 6 kg into 9.8. And what is the length means? The brass wire length is 1 meter, no, multiplying by 1 divided by area. Area we calculated 4.9 into 10 to the power minus 6 multiplied by brass, Young's modulus of brass. Somewhere I written, no, that is Young's modulus of brass value is given as 0.91 into 10 to the power 11 Newton per meter square. This is the Young's modulus value of brass. That value we have to substitute here, 0.91 into 10 to the power 11. Then find out the answer. Here 1 times, 2 times, that means 6 into 2 in the numerator 12 divided by minus 6 plus 11, that is plus 5, it goes to numerator, means 12 into 10 to the power minus 5 divided by 0.91. So find the value, calculate this answer. 12 divided by 0.91, that you will get delta L is equals to 13.18 or 13.18 into 10 to the power minus 5 meter, or change in length in brass, is equals to 0.13 millimeter. Okay, so this is the elongation produced in brass wire, and this is the elongation produced in steel wire. Yes. Listen here, this is a fifth problem over, and next one. Just now you are entering into the world of problems in physics. For that only I am explaining in briefly by writing the values and all those things. I hope you understood the method of solving the problem. So you can more fast in calculation than me also. Calculation is totally depend upon you, and you have to practice more number of problems. Then only you can score very good marks in physics. Okay. And next problem is, from here I'll give formula for the next two problems. Still two problems are there. I'll give formula and I'll tell the method. Try to solve. The edge of aluminium cube is 10 centimeter long. One face of the cube is firmly fixed to a vertical wall. So this is the diagram. You can assume, you can imagine a load is added here. How much the quantity of load means 100 kg. So F equals m into G. F equals 100 into 9.8 Newton. Okay, this is the force. And then shear modulus of aluminium. Aluminium shear modulus value is given. So eta for aluminium, that is 25 GPa, that is 25 into 10 to the power 9 gigapascal or Newton per meter square. 10 to the power 9 Pascal. So this is the value of eta. So what happens here? This is fixed, no. So the bottom layer will not, that means will not shift. Only there is a relative displacement between two extreme layers. The shape of this cube will become like this. And in this diagram, we have to find this vertical deflection. Already based on this, we have solved one formula. We have to find delta x. This is L, and L value is given what? Cube. This L value is 10 centimeter. What is the formula? Eta is equals to F A into theta, that equals F A delta x by L, that L goes to numerator, and here substitute the values of force and then length you substitute in meters, or 10 into 10 to the power minus 2. Area means here that is area equals 10 into 10 to the power minus 2 and 10 into 10 to the power minus 2. This is what area of the cube, right? So substitute the value of area and find the value of delta x. Then delta x is equals to, you can get delta x is equals to FL divided by A into delta x. Okay. Try to solve this problem. This is the method. Substitute the values, find the final answer. And the next problem, 4 identical hollow cylindrical columns of mild steel supported a big structure of mass 50,000 kg. The inner and outer radii of each columns are 30 and 60 centimeter respectively. Assuming the load distribution to be uniform, calculate the compressional strain of each column. So you can consider a identical cylinder, same cylinders, okay, made up of same materials. So this is the outer radii, and so from here to here, this is outer radii, this is inner radii, okay, of the hollow cylinder. So like this, there are 4 cylinders. On this cylinder, there is a mass. That mass is 50,000 kg. So we have to find the compressional strain. If we apply, so let us consider 4 cylinder like this, 50,000 kg mass if we apply means there will be a compressional strain. On one cylinder we have to find the compressional strain. The force is distributed uniformly means for one the force value is, mass is 50,000 kg. That means here 10 to the power 4, 5 into 10 to the power 4 kg into, this is m, and g value is 9.8. This is total mass. There are 4 cylinders. Per one cylinder how much mass? That for one cylinder the mass become, the force become F by 4. So divided by 4, okay, that means this will become the value of F. That is for 4 cylinder, F force means for one cylinder what is the value of force. Then the X value become F divided by, this is F divided by 4. And which formula we have to apply here? That is Young's modulus value of steel. We know that we have know the value of Young's modulus, Y equals FL divided by A into delta L, isn't it? We have to find the value of delta L by L. Delta L by L is strain. Delta L by L become F divided by A into Y. So this total value we have to calculate. For that, this is the value of F. And area, like this hollow cylinder means what area we have to consider? Normally area we will write pi r square, right? But here outer radii and inner radii both are given. That means the area becomes r2 square minus r1 square. Okay, like this, outer minus inner, that radius we have to consider. Then pi A equals pi into this r2 means 60 centimeter, 60 into 10 to the power minus 2 whole square minus r1 means 30 into 10 to the power minus 2 whole square. So pi value is 3.14. Okay, so this is the value of pi, this is the value of area. That area value we have to substitute here. And finally what is given? Y value, right? Y value is 2 into 10 to the power 11. Substitute all the values, find the value of delta L by L. I hope you understood these problems, practice these problems. Okay, and from starting only solve more number of problems in physics. Thank you.